All right, so now we're going to go ahead and get started with the string of analogies between the electrostatic representations of fields, potentials, and charges, and the magnetostatic versions. You remember that back in the chapter 2, I think, there was a diagram made that relates the charge to the potential to the electric field. Another graph like that was made for the vector potential, the current density, and the magnetic field, but it had a missing link. So one of the ways to fill this missing link is to exploit the analogy between the defining equations for A, visualize the divergence of A equals 0 and a curl of A equal B, and Maxwell's equations for B shows that the divergence of B equals 0 and the curl of B equals mu J. So evidently A depends on B in exactly the same way that B depends on mu naught J. Via the Biot-Savart law. So use this observation and write down a formula for A in terms of B. And then for part B, the electric analog to your result in A is V of R equal negative 1 over 4 pi integral E dotted with the script R hat over script R hat squared d tau. Derive it by exploiting the appropriate analogy for the magnetic version. All right, so the solution for A is they need to be related via the fact that B is equal to mu naught over 4 pi integral J cross R hat over script R squared d tau. Thus, A shows that 1 over 4 pi in replacing A with B and J with B, B with A and J with B, we get the same kind of analogous setup. Now, Poisson's equation says that del squared V is equal to negative rho over epsilon naught, all right? But for dielectrics with no free charge, the bound charge is equal to the negative divergence of the polarization. And the resulting potential is V equal 1 over 4 pi epsilon naught with the polarization dotted with the script R vector all over the script R or separation vector squared in the space. So in general, we say that rho is equal to epsilon naught with the divergence of E. So the analogy is that P goes to negative epsilon E, and hence V equals this potential. All right, fair enough.